Today we're looking at the second half of 8-6, which is rational exponents. And what a rational exponent is a ratio of integers, but the denominator can't be 1, so it looks like a fraction. So the example I have here is x to the 2/3 power. The denominator gives you the root, so this can be rewritten as the third root, and then the numerator, sorry my calibration's off, gives you the power. So the third root of x squared can be rewritten as a rational exponent, x to the 2/3 power. So again, the denominator is the root and the numerator is the power. So we're going to look at converting between radical notation and rational exponents. And then we're also going to look at simplifying with rational exponents and radical notation. We spend 2 days on simplifying with radical notation, so simplifying rational exponents is no different. You just have to make sure that you think about it as a root when you're looking at that fraction. So our first example is 32 to the 3/5 power. So again, 5 is the root. What I like to do is take the root first because you're making the number smaller and then raise it to the power. You could do 32 to the 3rd power and then take the 5th root of that. But I definitely don't want to do 32 to the 3rd power without a calculator, but I can do the 5th root of 32 without a calculator. So I'm going to start with that. And this is an alternate notation. So the one I gave you last time, I had the power on it under the radical. You can do this in any order. It's like multiplying. You can multiply 3 times 4, or you can multiply 4 times 3, and you'll get the same answer. You can take the root and then the power, or you can take the power and then the root and get the same answer. So the 5th root of 32 is 2. 2 cubed is 8. So that would be the simplified form of 32 to the 3/5 power. All right, so our second one, we have the 6th root of 5 cubed. Well, 5 is definitely not a perfect 6th. So I'm going to go ahead and rewrite this as a rational exponent. Remember, the power goes in the numerator, so in this case, 3 is the power, and the root goes in the denominator, so 6 goes in the denominator. So what I notice is 3/6 simplifies to 5 to the 1/2 power. Now, I'm going to convert this back to radical notation, even though this is my final answer, because I was asked to convert to rational form. But just so that you see what 5 to the 1/2 power is, remember the denominator is your root, so it's the square root of 5. So whenever you see a 1/2 power, it's the same thing as taking a square root. All right, looking at some more simplifying, a little bit more complicated simplifying than we saw on the first page. So I've got 144 to the negative 1/2 power. Well, we just saw that the 1/2 power is the square root. So I'm going to take the square root of 144, which is 12, and then I didn't do anything with the negative, so it's still to the negative 1st power. Remember, whenever you see a negative exponent, it means move it to the denominator if it's in the numerator, or move it to the numerator if it's in the denominator. So I end up with 1 over 12 to the 1st, or 1 over 12. For part B, again, I can do this in either order because it's multiplication inside the parentheses. I can distribute this 2/3 power to each of my terms inside. I don't want to multiply 8 times 64 and then raise it to the 2/3 power because I would need to pull up my calculator. However, again, I can do 8 to the 2/3 power, and I can do 64 to the 2/3 power without a calculator. So again, the denominator means the root. So I'm taking the cube root of 8, which is 2, and then squaring it, so that's the numerator. The cube root of 64 is 4, and it's still to the 2nd power. So I take care of that denominator before I take care of the numerator. 2 squared is 4, 4 squared is 16, and 4 times 16 is 64. All right, next example, I've got the same base. My base is 2 raised to different powers. So think about, for example, if we had something like x squared times x to the 4th, what would we do with those exponents? We would add them. So we do the same thing here. As long as it's the same base, we add the exponents. Now don't forget how to add fractions. Sorry about that, the calibration. 1/2 plus 1/4. When we add fractions, we need a common denominator. So my denominator in this case is 4. So we get 2/4 plus 1/4. I'm sorry, I need some parentheses. Which is 3/4. So it's 2 to the 3/4 power in simplified form. This is our last page of examples, and now they're getting a little bit more complicated. So again, let's take a look at D. We've got the same base. My base is 12. So what do I do with the exponents? Think about it if we had, oh, sorry, something's really wrong with this. I thought I'd be in and out quick because it's a short lesson. This is our last page. All right, so think about if we had, sorry, I wanted to think about with x. If we had x to the 5th power over x to the 3rd power, what would we do with those exponents? We would subtract them. We're going to do the same thing with these powers. We will subtract them. So it's 12, oops, to the 1, too close to the top of the screen, 1/4 minus 3/4 power. Sorry, I hope you can follow this. So we're subtracting the exponents. Subtract the numerator minus the denominator. Let me shift this up a little. All right. So I've already got a common denominator, so when I subtract my numerator, 1 minus 3 gives me 2, a negative 2. So I've got 12 to the negative 2/4 power. I'm going to simplify my exponent. 2/4 simplifies to 1/2. So I have the negative, or the reciprocal of the square root of 12. I'm going to look at the 1/2 power first, and I'm going to pull that negative 1 out. I'm going to put this in radical notation because that's what you guys are used to seeing versus the rational exponent. So again, then square root is because it's the 1/2 power, and then the negative, I'm just raising to the negative 1 power, so we'll take care of that in a minute. Now to simplify the square root, we find a perfect square factor. So the square root of 4 times the square root of 3 is the same thing as the square root of 12. So I simplify that to 2 times the square root of 3. And that negative 1 means it needs to go in the denominator. So it becomes 1 over 2 times the square root of 3. So of course we have to rationalize the denominator. We're going to multiply by root 3 over root 3. Nice that this is a square root, so we don't have to think too hard about how to rationalize that denominator. So I get square root of 3 over 2 times 3. Remember, the square root of 3 times the square root of 3 is the same thing as the square root of 3 squared, which cancels. So 2 times 3 gives me 6 in the denominator. That one's longer than I gave myself room for. All right, 2 more. So the next one, I've got a power of a power. Remember, if we had something like x cubed to the 5th power, think about what we would do with those exponents. Power of a power rule says we would multiply. So we're going to do the same thing here. There's a couple of different ways to do this. I think so that I don't lose you too much, I'm just going to multiply my numerator times my numerator, so I get 1 times 6. And my denominator times my denominator, 3 times 5. And then I'm going to simplify my exponent. So they're both divisible by 3. So I get to the 2/5 power. So what I would have done looking right here is remember that this fraction bar that was in front of the 3 means divide. And I would have done 6 divided by 3 right away to get 2 from my numerator. And then the 5 is left in the denominator. So now I'm going to think about the denominator means the root, the 5th root of 243. This was one of the ones on the chart that I gave you, so if you don't have it memorized, you might want to take a minute to think about it or to look back at your chart and see what you can come up with. And the 5th root of 243 is 3, and 3 squared gives us 9. Remember, the numerator is the power, Denominator is the root. That's really all you have to remember with these rational exponents. Everything else you already know. You've already worked with properties of exponents. So they're not as scary as they first look. Last example. So we've got everything to the negative 1/3 power. So I'm going to take my 27 in the numerator to the negative 1/3, and I'm going to do the same thing in my denominator. So first I'm just going to go ahead and distribute that exponent that's on the outside. And in the denominator, remember, like we just saw on part E, the power of a power rule means multiply. So multiply your numerator, 1 times negative 1. Multiply your denominator, 3 times 3. Then I'm going to simplify my negatives by flipping. So my 27 to the negative 1/9 will move to the numerator, and my exponent will become positive. And then my 27 to the 1/3 will move to the denominator. Because they have the same base, I can subtract the exponents. But because I know 27 is a perfect cube, I'm going to go ahead and simplify that in the denominator. (27 to the 1/3 power is 3. I'm thinking about if I wanted to subtract the exponents. So I'm going to try that and see where we get. I think I might want to do it this route because then I end up with 1 power. But we'll see what happens. So the 1/9 minus 1/3 becomes 1/9 minus 3/9. So we get negative 2/9. No, I think I like doing it the way that I did it better because 27 isn't a perfect 9. So we're left with 27 to the 1/9 over 3. Or if you like that in radical form, the 9th root of 27 over 3, either one. All right, that is it. So tomorrow we will have a chance to practice some of these in class. Hope you're having a great weekend.